AOS 3, calculating energy content of food. So in this section, we'll address mostly 2 points. The first is the comparison of energy values of carbohydrates, proteins, and fats and oils. That includes we need to know how to calculate the energy content of food based on percentage composition. The second point is to know that glucose is a primary energy source of our body, and we need to know a balanced, well, you can balance it, the thermochemical equation for cellular respiration. So a little bit revision. We talked about units of energy when we were in chapter 2. Yeah? The units of energy is joules, and larger amounts can be expressed in kilojoules, and the conversion is 1,000. And we had with food, sometimes you will see they are calculating calories. 1 calorie or kcal equals to 4.184 kilojoules. And do you remember how to convert between kilojoules and megajoules? There it is, in case you forgot. Okay, so energy content and energy value, they're actually 2 different things. When we say energy content, that's the energy released by something going through combustion reaction. So everything that's burnt out, and then the amount of energy released. So basically that's what anything or any food actually has in terms of energy. However, not all those energy from those energy content can be used by the body. Therefore, energy value is the actual amount of energy available for our body to use. So you can see that carbohydrates, almost all those energy from carbohydrates can be used by our body. However, for proteins, there's a significant amount of energy lost in in the process when our body try to actually utilize the energy coming from those proteins. For fats and oils, they're relatively the same. Yeah, so whatever that comes in can be used by our body. So energy content is usually larger than energy value for this reason. Well, if you break it down to see, you'll see that mostly our body doesn't really absorb all the nutrients that come from every single food. Yeah, and sometimes the food are not completely oxidized to be used, for example, proteins or some of those insoluble fats. And during digestion, there will be heat loss. And also, not all the molecules can be digested. So, for example, if you eat a lot of vegetables, vegetables actually do have significant amount of energy. It's just we can't really use it because we don't have the enzyme needed to digest dietary fibers. Okay, some of those dietary fibers are also part of carbohydrates. Yeah, so vegetables don't really give you much of energy, but they do give you a lot of other nutrients. If we compare the energy content or energy value of carbohydrate, fats, and oils and proteins, we'll come to such conclusions. First, carbohydrates, the energy from carbohydrates is the most readily used. And fats and oils, they are actually the most energy dense program of nutrients. And they store a lot of energy. But when our body still has carbohydrates break it down, we will use the energy content from carbohydrates first before we resort to fats and oils. And proteins, the amino acids that make up proteins are rarely used for energy as they are needed to build new proteins. However, when our body is in starvation, then we'll actually just use whatever that is readily available. So we will break down proteins. So you will see that people in starvations lose muscle mass. Well, how do we calculate the energy value of food? Good news. These three figures, basically the energy content of these three different nutrients, are given by our data book. Yeah. So if we know the percentage composition of food, then we'll be able to use this table to calculate how much energy a food actually comes with. Hmm? So for example, in this question, a sample of white bread is 53% of carbohydrates, 8% protein, and 4% of fat, and 35.5% water. What would be the energy content for this white bread given in kilojoule per gram? Okay, this is what you often see at the back of a package of food. Yeah, giving you the nutritional facts. Well, first of all, if you feel uncomfortable directly using percentage, in your head, you can always assume that there is 1 gram of bread. Okay, so since we are calculating energy per gram, we'll just assume that there is 1 gram of bread. So in that 1 gram of bread, 0.53 grams are carbohydrates. So you time the energy value, the heat of combustion of carbohydrates to get that energy. Yeah, and you do the same thing for protein. The amount of protein in that 1 gram of bread times the energy, the heat of combustion of protein, which is 17 kilojoule per gram, and you get the respective value. And for total energy, you just need to add all these three together. What do we do with water then? Well, water doesn't really give out much of energy. Yeah, we assume that water gives no energy whatsoever. So if you really you're hungry, you're starved, drinking water doesn't really help. Okay? Now, you can give it a try. And from this example, you can actually see that sometimes the questions might not give you the percentage of water, but that doesn't matter. The only thing you need to do is look for the percentage composition of carbohydrates, protein, and fat and oils. Yeah? Well, as I said, percentages don't necessarily add up to 100%. Okay? But water does not really need to be counted. Cellular respiration. Well, glucose is the primary source in the body, primary energy source in the body. It can be oxidized to make carbon dioxide and water by the process of cellular respiration. So basically how our cells breathe. This transfers the chemical energy to a molecule called ATP, adenosine triphosphate. Well, hard to pronounce biology words, which can then be used for cellular reactions. Well, there are two ways our body can utilize glucose. We can utilize glucose through aerobic respiration, which requires oxygen. It is the body's main source of energy. Yeah, it's basically glucose, if you know the molecule glucose, and plus oxygen, becoming carbon dioxide and water. And I trust you are able to, as a chemistry student, balance this equation by yourself. Yeah, and you can see that it gives out about 2,860 kilojoules per mole of glucose consumed. Yeah. However, sometimes oxygens are not readily available. For example, when you are doing weight training or when you're running really fast for a really long period of time, then your body doesn't supply an oxygen as fast enough. Then anaerobic respiration takes place. This reaction, it produces much less energy per mole of glucose. You can see that the heat produced by this reaction is only 120 kilojoule per mole. However, it is a lot faster compared to aerobic reaction. Therefore, when our body really needs energy, but it doesn't get supplied enough oxygen, then this reaction, anaerobic reaction, will naturally take place.